Okay, we've been working all chapter long on graphing linear equations, and we're going to keep graphing them, but today we get to graph linear inequalities. So rather than seeing an equal sign, we're going to start seeing inequality signs. Okay? So the only thing different is that sign. So we know that slope-intercept form, let's say it together, slope-intercept form is
y equals mx plus b.
So instead of seeing that equal sign, we will see an inequality sign there, like greater than or less than. Okay? So it might look like y is greater than mx plus b. Okay? So the solution of any statement like this, an inequality or an equation, is what? Can somebody give me a number we could use for slope? What number could we use for slope? Gavin? 2. So we could plug in a 2. Y is greater than 2x, and then I need a number for your y-intercept, and well, plus 3. So if you have that inequality there, which actually has slope and a y-intercept, how could I find a solution to this inequality? What would that look like, do you think? Colin?
If you subtract 3 and subtract 3 from 1.
If we subtracted 3, would that give us a solution though? How did we find solutions for linear equations? Not inequalities, but equations. What did we do? What can you find when you have this sort of a thing? Aiden? You can find the line. How do you find it? You could use that. And then what else could you do? The first thing we ever did was make a table. What did we find using our table? Brian? We found y-intercepts. What else did we find, Teddy? Points. Anything that would make this inequality true would be a solution, right? So right now, if we plugged in, let's say we plugged in 0 for x, what could we call y? And the statement would be true. Lauren? 4. Does everyone see that? If we plugged in 0, 4, that point, then when we multiply and add, we have 4 is greater than 3, right? And so that point she just named, 0, 4, is a point that works in this inequality. And if it does, then you have a solution. Okay? So solutions are a point that makes an inequality true. And when we go graph inequalities, we end up graphing whole half planes. Not just a line, but a line and then a whole half plane we're going to see today. Okay? The first question you'll have, though, is just simply, can you test a point and state whether it is a solution or is not a solution? We always do that when we're starting, don't we? We test things. So we're going to test some points to see whether they are solutions or not for this inequality. 2x plus 3y is less than 5. We have a point 0, 0, right? How do we test that point? Plug it in, plug it in, plug it in. That's what I say. So we take the inequality, right? We don't even have to change it to slope y-intercept form. We're simply testing this point. We need to make sure we plug in the numbers in the right place, but in this case the numbers are the same. They're both zeros. So we would have a hard time making a mistake here. We plug in 0 for x and 0 for y. And I'm going to put a little question mark over that sign. Is this true? Is 2 times 0 plus 3 times 0 less than 5? And it is, because what do we have on the left? 0. 0 is less than 5. So we would say this is a solution. Okay? So go ahead and test all of these points and determine which ones are solutions and which ones aren't. Okay? And then come back and check your work here. Right. So good. So if this had less than or equal to, that sign, instead of just less than, it would be true. You're right. it would be a solution. So when you have an equal bar underneath your greater or less than sign, it does change the possibilities, right? Just a little bit, you have that added point right there. So this would be true, but the way it is now, it's not a solution, okay? Okay, we're now going to graph using our inequality here. Okay, so go ahead and get your paper ready to graph. Okay, you have learned a lot about graphing linear equations already. And so you will kind of have fun with this. This is interesting, a little more interesting. Instead of the equal sign, we have a less than sign. See that? So we start by graphing this just as though it has an equal sign. Okay, so we're going to graph a line. And so what do we know about the line looking at that inequality there? What can you tell me about y equals, or y is less than 1/2 x minus 1? What can you tell me? Stuart?
It's going to be positive.
Okay, it's going to be positive because what is the slope? It is 1/2. So just as we found the slope with an equal sign, we can find the slope with an inequality, right? And then what is the y-intercept, everybody? -1, good. So we can go right now and plot the y-intercept. Remember, it's y-axis, y-intercept at -1. And we can just use a slope to find a second point. And let's use the R words for slope. Slope is?
Rise over run.
Good, so let's make sure we do that from that starting point we just found. From the y-intercept, we rise 1 and we run 2. And we could do that again if we want. Rise 1, run 2. Okay? And so we're ready. We could draw a line, right?
Yes.
Okay. The problem is, well, as we look at this inequality, y does not equal this line. Do you see that? There's no equal sign underneath that less than sign. So the points on this line are not solutions to the inequality. So we do need to draw a line, but we need to draw a line that shows that the points are not solutions on that line. So can anybody think of what type of line we could draw that shows that the points on it are not solutions? Okay. Zigzag, that's a good guess. Not quite zigzag because it actually forms a straight line. So we just need to do something a little different with it. And Teddy?
Is it line segment? Is that the arrows?
Actually, there are arrows on the end, but Olivia? No, it's not just a ray. These are really good ideas, though. Good thinking. Brian? No, it's going to look like the shape that we see here. Jake?
A squiggly line.
Not squiggly. Okay, how about this? A dashed line. Okay? So, because there is not an equal sign under that inequality, the line doesn't contain solutions, but it contains a boundary. So we draw it as a dashed line. But we know that there are solutions to this inequality, and there are a whole bunch of them. One of the planes, either the side above the line, whoa, back that up. Either this area above the line are points that are all solutions, or it's the area below the line. So how can we figure out which area it is? Any ideas? What could you do to figure that out? Anyone else? Brian? Plug what in? Good job. Excellent. We call this testing a point. Okay? We're going to test a point to see if it makes that inequality true, just like we did in the previous slide, right? We have our inequality, y is less than 1/2 x minus 1, and we're going to choose a point that's not on this line, but either in the top plane or in the bottom half plane. So does anybody see a really easy point we could use to plug into this inequality? What's the easiest point in the world there? Emily? 0, 0. Good. We're going to test this point 0, 0 right here and see if that point, since it's not on the line, is a solution. Okay? So let's plug it in. 0 is less than 1/2 times 0 minus 1. Is 0 less than 0 minus 1? What is 0 minus 1?
Negative.
Negative what? Is 0 less than negative 1?
No.
No, not a solution. So the test point is not a solution. So guess which half plane contains all of the solutions? Would it be where the point is or the opposite one? Opposite. It's this area all down here. We shade it in. All of these points are solutions to the inequality. And if you want to, you could test any point down there and they will all work. Okay? So do we want to test one to prove that?
Yeah.
Okay, so Alex, give me a point.
-1, -3.
-1, -3 is right here. Okay? He's choosing to test -1, -3 in our inequality. So let's plug it in. We say -3 is less than, again, we're using this inequality, 1/2 times -1 minus 1. So -3 is less than, what is 1/2 times -1? -1/2 minus 1, which is two negatives we're adding, right? So what is -1/2 plus -1? -3 is less than -1.5. Is that true? Is -3, look at the number lines up here, is -3 less than -1.5?
Yes.
You see, it's to the left. So it is true. This point is true. Had we chosen that point, we would have found that the point was true, and so we would have shaded the side where that point was. So when the point, your test point is true, you shade the side it's on. If the test point that Emily chose up here, if you test a point that's not true, you have to shade the opposite side. Okay, thumbs up if you understand? Good. Steps to graphing inequalities. So the first step was we graphed the what? We graphed the inequality as though it was a line, right? We changed it to basically an equation and we graphed it. But we said if it is a less than or greater than and does not have an equal sign under it, the line has to be dashed. So often that's forgotten because we're so used to drawing straight lines with a ruler and we just forget to dash it. So sometimes we need to write the word dash right away when we see this so we don't forget. Okay? And the second thing we did was tested a point on either side of the line, not on the line. It must be on either side so that we could determine which side to shade. And let's put a little note that if the test point is a solution, it works, it's true, then we shade that half plane. But if the test point is not true, is not a solution, then we have to go shade the opposite half plane. Okay? And this will take some practice. Okay, let's do it again. We have 3x plus y is less than or equal to 3. Okay? There are a number of ways you have learned to graph. You could make a table. You could find your intercepts, the x-intercept and the y-intercept, and plot those, right? Or you could use your slope y-intercept form. So why don't we use the slope y-intercept form? Who can help put this into that form? Gavin?
M
Well,
over 1.
you're going to have to get y isolated if you want that form. So how do we get that isolated?
So you subtract 3x.
Good. Subtracting 3x, and then can you say this inequality in that form? Y
Is less than or equal to
negative 3x plus 3. Good job. Okay, so we have this favorite form, slope y-intercept. So everyone, tell me, what is the slope? Good, negative 3 over 1, right? And what is the y-intercept? 3. 3. Okay, so we have our graph. We go graph. So we plot what first? What first, Jake?
3.
The y-intercept crossing the y-axis at 3, good. And then we use our slope, right? We start at that starting point. That is our starting point. And where do we go, Audrey?
You go negative 3,
Uh-huh.
and then is it 1? Yeah,
Positive 1, good. So we go down 3 and to the right 1.
And
Down 3,
dash.
and we can keep doing that. And should this be dashed or solid?
Solid.
Solid, why solid?
Because it has the underline.
Yes, because it has the equal sign, okay? So that kind of tricked you a little bit. Do you see why? Solid, okay? And now the final step is determining which side to shade. So what point would you like to test? Do you want to test 0, 0? It is the easiest point to test. Is 0, 0 on the line?
Yes. No.
No. So could we use it?
Yes.
So why not use it? Okay? We can actually plug it into the equation that, or the inequality that we created here. So negative 3 times 0 plus 3. So is 0 less than or equal to 0 plus 3?
Yes. Yes.
0 plus 3 is
3.
3. So is 0 less than or equal to 3?
Yes.
Yes. So this time the point 0, 0 worked. So where will we shade?
Below the little dot.
Good job. Toward that point, this whole side.
Oh, I
Okay, good. Yes. Try graphing this linear inequality and come back and check your work. Good job. And that's it. Okay. And so here we go with our assignment.